Here's the guide for factoring polynomials. We need to start with the common monomial factoring. Then whatever will be the result, we're going to categorize them as to whether the result is a binomial, trinomial, or multinomial. And we have specific processes under specific results. Then we end it. Let's start with this polynomial. To factor this given trinomial, we need to consider whether this is a perfect square, or if it's not, let's try to use another method. Because there are two possible methods when we factor quadratic trinomial. This is known to be a quadratic trinomial because in the first place, it has three terms, and we have here the decreasing powers of a singular variable. We have x squared, x, and 9. That can be considered with a variable x to the power of 0 is just equal to 1. So we can examine this first, whether this is a perfect square or not, and if it's not, we proceed with another method. The first condition in identifying whether this is a perfect square or not is to look at the first and the third terms. This is the first term, this is the third term. Our first term is x squared, and it's a perfect square, so we have met the first part of the condition. The third term, which is 9, is also a perfect square. So the first condition is just to examine whether the first and the third terms, or the term with x squared and the constant, are both perfect square. So it is already okay. The second condition for us to determine whether this is a perfect square or not is by looking at the middle term. Okay, 6x. The middle term, or the second term, must meet this criteria. It should be the product of twice times the square root of the first. Okay, since the first is already a perfect square, we're sure that we could take a square root of it, and also the square root of the third term. So if we could establish this idea, then we are now sure that it's a perfect square trinomial, and we could proceed with the factoring specifically for perfect square trinomial. So our second term is 6x. So let us check if it meets the criteria here. So twice the square root of the first term, square root of x squared, is simply x. That's x. And the square root of the third term, square root of 9, is 3. But take note, whenever you consider a square root of a constant, we have two possible results, the plus, minus. So we have the result. But this is not 2 plus 3 or 2x plus 3 and 2x minus 3. Okay, these are all under multiplication. So our second term is 6x. And there are two possible results for a middle term for having this first and third terms be called a perfect square trinomial. 2 times 3, so you have positive and negative 6x. So you have two possible results now. And since one of which is a positive 6x, so we have established that our second term meets one of the possible criteria for the trinomial to be called a perfect square trinomial. And we check that. So with these two conditions already met, we are now sure that it is a perfect square trinomial, and we can proceed with this factoring. The factoring process of a perfect square trinomial follows the simplified form of a square of a binomial. This is its factor. So we just simply take the square root of the first term, square root of x squared is x. Square root of the third term, 9, is positive and negative 3. But which of the two? We use the sign of the middle term, plus. So this is now, or this 2, because we could write here, when we say square of x plus 3, it means there are 2 binomials of x plus 3 multiplied with each other to get the result. So these are now the result, or these are now the factors of x squared plus 6x plus 9. So whenever you have a perfect square trinomial, you could expect a square of a binomial or 2 binomials of the same expression multiplied with each other. So again, these are the conditions and these are the results on factoring the given. The next factor we're looking for is for our next subscriber. Subscribe now!